Hello everyone. Welcome to today's session on uh, CBSE Class 11 Mathematics, and we'll cover trigonometric functions. So, in trigonometric functions, let's look at the angles in radians and degrees. So, we all know what angle is. So, let's see how we measure in degrees and radians. So, in this session, our learning objective is by the end of this session, right? So, the students will be able to one. So understand what angles are and how they are measured, and convert the angles between degrees and radians, and also solve some basic problems involving degrees and radian conversions. And also we will cover few real world applications. All right. So let me move here. So first let's look at the introduction to angles. So what is an angle? We know, right? So in trigonometry, we have learned in our previous classes like 30 degrees, 40 degrees, 60 degrees, 90 degrees, right? So basically what is an angle? So if we take an array, right? So this is the initial side, right? So let's say OA is a ray, right? So OA is a ray that is at the initial side, and then it is moving to a position OB, right? So what is happening here? A rotation is happening. So this rotation we can denote as angle, that we can say theta. Okay. So basically what is an angle? The measurement of the rotation of any ray from initial position to the terminal position or the end position. That is the angle. So basically what we can say, the angle is the measurement of angle is the measurement of a ray from initial side to the terminal side. Initial side to the terminal side. You following, right? So the measurement of rotation, right? So the measurement of rotation of a ray from initial side to the terminal side, that we can denote as theta. So here if we see, this is moving in a anti-clockwise, right? You know, right, how clock rotates, right? So this is anti-clockwise. If we see here, this is the way that clock rotates. So this is clockwise. This is clockwise. This is also theta. This is going down. This is going up in the anti-clockwise direction. So if you look at the last diagram here, so this is like the initial side and the terminal side are coinciding. That means it has made a full rotation. It has made a full rotation. That means it is moving in a anti-clockwise direction. That we can say full rotation is 360 degree, the whole angle in the circle. So that is 360 degrees. Now there is a sign convention also, right? So all the anti-clockwise angles are positive and the clockwise angles are negative. So the sign conventions here are, the sign convention is anti-clockwise or anti-clockwise angle we can measure in positive, like plus 30 degrees, plus 90 degrees, right? Plus 180, like that. Then clockwise. So clockwise angles we will measure in negatives, like minus 30 degree or minus 45 or minus 270, like that. Okay. Now the angles can be measured in two variables. So that is, one is degree, which we know, and here we will learn degrees and radians. This is a new term that we will learn, how we will measure the angle in radians. Okay. Angle can be measured in two variables, that is degree and radians. So here you understand, right? What is the angle? So the angle is the measurement of the rotation from its initial position to the end position. Okay. It can be clockwise or anti-clockwise. Anti-clockwise angles we take positive, and clockwise angles we'll take as negative. And the full rotation, when the initial position of the ray coincides with the end position, right? Then what we can say, that ray has made a full rotation. That full rotation is 360 degrees. Okay. Now let's see what is a degree, right? So what is a degree? The full rotation, right? The first diagram here, the full rotation is 360 degrees, right? So let's say I have a circle here. Let's say this is the center. Let's take the clock, right? So let's say the clock, let's say this is a minute's hand. So if this minute's hand is, hold on guys, if this minute hand is rotating full, right? It rotates in the clockwise, but let's say it has made a full rotation, then we will say 360 degrees, right? Then what is 1 degree? 1 degree is nothing but 1 by 360th of rotation. Can I say that? 1 by 360th of rotation of the ray, rotation of a full rotation of the ray. So it is 1 by 360th portion. That is 1 degree, right? So here, if you see the second diagram, starting from here and it is going up to here. So that is 180 degrees. And here it is going straight and then it is going further by 90 degrees. So this is 270 degrees. And 360 we already know, right? So in a quadratic plane, guys. So let's say in a quadratic plane, from here to here, so this is 0 degrees and this is 90 degrees. This is 180 degrees. If the rotation is up to here, then it is 180. And then this is 270 and this is 360 or 0, both, right? So this is 270 and this is 360. You understood? So that's how we measure the angles. So if we between 0 and 9, this is the first quadrant. Between 90 and 180, this is the second quadrant. And 180 to 270 is the third quadrant. And this is fourth quadrant, 270 to 360. And if we go in the other direction, this is what? Anti-clockwise. So all the angles that we measure is in positive. If we go in the other direction, for example, we are going from here, right? So 0 to 270. So we are going in the opposite. So this we can measure as negative angle. So this is the clockwise. So the clockwise angles are negative and anti-clockwise angles are positive. So if it is doing more than 360 degrees, for example, this figure here. So this is, it has made a full rotation plus 360 degrees plus some more angle. So you need to add to 360 plus that angle. So that's why it is 420 degrees. It is still positive because it is going in the anti-clockwise direction. Now here, if you see, this is coming in the clockwise direction. So this is a negative angle. Similarly, here, this is going in a clockwise, right? The clock rotates like this. So this is also a negative angle. Understood? So what is degree? A degree is 1 by 360th portion of a full rotation, right? So each, if I divide that full rotation into 360 parts, then that one part is nothing but a degree. Now let's look at, so degree is denoted by 0 at the top, right? Like 30 degrees, 40 degrees, like that. Now let's look at what is a radian, right? The other new term I said, right? The new term is a radian. So radian is basically, it is a measurement, one of the measurements of angle other than degree. And how it is, if you consider a unit circle, consider this figure here, the first figure. So if you consider a unit circle, means whose radius is 1 centimeter. The radius of this circle is 1 centimeter. With 1 centimeter, if I draw a circle with center as O, then what is this AB? AB is the arc length, right? AB is the length of the arc. So if the arc length is equal to the radius or that 1 centimeter, then the angle subtends by that arc at the center of the circle is called 1 radian. So basically 1 radian is if a unit circle, right, 1 centimeter radius with arc length is 1 centimeter, whatever the angle that it subtends at the center, that is called 1 radian. That means total angle. How much is the total angle in the circle? Total angle in the circle is 360 degrees. That should be equal to the length, the total length of our circumference. This is total length of the arc, right? That equal to total length of arc. So what is the total length of arc? It is basically the circumference, right? That equal to circumference of the circle. Following, guys? So what is circumference of circle? 2 pi r. In this case, what is r? R is 1. So it is basically 2 pi into 1. So 360 degrees. 360 degrees is 2 pi into 1, which is 2 pi. So 2 pi radians. 1, right? 2 pi radians equal to 360. Or I can say pi radians. Pi radians equal to these two I will send to the other side, then it becomes 180 degrees. Or if I want 1 radian, so 1 radian equal to 180 degrees by 1. You're following? So what is pi value? Pi value is either 22/7 or 3.14. If I substitute that value, that's what I will get as 1 radian. So that 1 radian value, if I calculate, if I divide with by 27 or 3.14, I'll get as 57 degrees and 16 minutes. So I need to do this as well. So in a circle, right? So 360 degrees, right? The full rotation is 360 degrees. And there is also 1 degree, we can also say as 60 minutes. Okay. And also minute is denoted by a 1 at the top. And also 1 minute we can denote as 60 seconds. 2 dotted lines up. Okay. So this is just a note for you guys. Okay. We'll do problems, then you will understand. So now, do you understand like what is a radian? A radian is such a thing that the angle subtends in a unit circle at the center when the radius equal to the arc. When the radius is equal to the arc length, then the angle subtends at the center is nothing but 1 radian. So the full circle is 360 degree, and that is the total circumference of this circle. That is 2 pi r. As it is a unit circle, so r I will substitute as 1. So 2 pi radians is 360 degrees. So pi radians is 180. So 1 radian is 180 by pi. If I calculate that value, it is coming as 57 degrees 16 minutes. You understand? So that's how we can calculate or convert degrees into radians or radians into degrees. Okay. So what is the relation between the degrees and radians? So what I said, 2 pi radians, right? 2 pi radians is equal to 360, right, guys? This is what we learned. So then 1 radian is becoming 1 radian equal to 180 degrees by pi, because the 2 I send to the other side, then the pi also I'm sending this side. So 180 degrees by pi. So if you want to convert an angle into radians, then what you need to do is to multiply with it. And similarly, from here, we can say if 360 degrees equal to 2 pi radians, then what is 1 degree? 1 degree equal to 2 pi by 360. You following, guys? 2 pi by 360 radians. Or 1 degree I can say pi by 180. Right? So if you have a value in degrees and want to find in radians, then you need to multiply with pi by 180. And if you have value in radians, want to find how much angle it is, then you need to multiply with 180 degree by pi. Yeah. Let's do some example. So 30 degree. 30 degrees, I want to convert into, look at the table here. I have pre-populated all the values. Okay? So let's say 30 degrees, I want to convert into radian. So what is the conversion factor? Into, I want to convert into what? Radian, right? So if 1 degree is pi by 180 radians, 30 degrees is T into pi by 180. 1, right? Equal to pi by, following guys. And similarly, take any angle. I want to, let's say I want to convert this, right? So what is this? 360 into what is 1 degree? 1 degree is pi by 180 radian. Pi by 180, 180 once and 180. That is 2 pi radian. So this is the relation between degrees and radians. So want to convert, you know, the radian and want to convert into angle. For example, let's take this. Let's take this value. This is the radian value, and I will convert into degree. Say 3 pi by 2, guys. 3 pi by 2. If I want to convert into degrees, 3 pi by 2 radians into how many degrees? This formula we need 180 by pi. 180 by pi. So pi gets cancelled, and then 2 ones and 2 90s. So 3 into 90 is 7. You following? So that's how we know a radian value we can convert into degrees, or if you know a degree value we can convert into. And the multiplication factor is, if you know a degree, then pi by 180. If you know radian, then into 180 by pi. Okay, let's do some problems here. Now convert 72 degrees into radians. Okay, so how to do this, guys? So I know degrees, right? 72 degrees. I want to convert this into radian. Can I write this as 72 into 1 degree is what? 1 degree is what? Pi by 180. That's what we learned, right? So I'm converting into this now. Let's say 9872 9 1. Then 4 2's 4 5. So can I write this as 2 pi by 5 or 0.4 or 0.4 into 3.1. Multiply, that's what the way. Or you can leave up to here, the radians. Or you can just write 72 degrees equal to 2 pi by 5 radian. Okay. All right. Now let's look at, we talked about 1 degree, right? So we talked about 1 degree is 60 minutes. 1 minute is 60 seconds, right? So that we will see here. So now here we need to work 40 degree and 20 minutes into a radian method. Right? So first convert this into an angle. 40 degree and 20 minutes, right? So in minutes, if I want to convert into a degree, right? So 20 minutes, I can say 20 by 1 minute is 1 by 6. 20 minutes is 20 by 6. So this I can say, is that 20? Yeah. So 21, 23. So it's 1 by 3rd degree, 1 by 3 degree. So can I write this as 40 degrees 1 by 3 or 40 degrees 1 by 3, 40 1 by 3 degree. Or we can also write this as, if this is like a mixed fraction, right? So 43 is 120 plus 1. So 121 by 3. So this is the, what I did, I converted the minutes into degree, and then it is a mixed fraction, and then converted into. So now it is 121 degree by 3. So if I convert this into a radian, so what I need to do? What is the multiplication factor, guys, to convert into radian? That is pi by 180. So pi by 180. Mm, yeah, let's see. Simplify this. So this becomes 121 pi by in 3 is 54 by 4. This is kind of, so you can live up to here, like 121 pi by 540 radians. Or want to simplify, what we can do is you can divide 121 into pi value, you can substitute. So 121 into 22 by 7 by 540, right? So then this becomes 121 to 22 by 540. If you start simplifying this, yeah, if you simplify, you will get that value into radian. So what you can say, 40 degrees and 20 minutes equal to 121 by 540. Yes, on the pi value and divide that. I suggest that you can leave up to pi value. Okay. All right, guys. Now let's look at the other thing. Here, what we did, we converted from degrees to radian. Now let's look at how we convert radians to degrees. Okay. So here, convert 3 pi by 4, right? So let's solve this, right? So 3 pi by 4, that is in radians, into degrees we need to convert. So what is the multiplication factor, guys? That is the reciprocal of that, which is 180 by pi. So pi gets cut. Then this become 3 into 180 by 4. Let's see, 4, 4, 15, and then 2, 4, 5. 45 into 3. 120. So 135. Got it, guys? So 3 pi by 4 radians equal to 135 degrees. Okay. Hope you are following, right? So now convert 6 radians into degrees. 6 radians, right? So 6 radian equal to, into what is the conversion factor? 180 by pi, right? So what we can write is, uh, it is basically 180 into 6 is what? 1008. Now you can live up to here or just measure this. 6 into 0 is 0, 6, 8, 40, 4, 6, yeah, 1080. 1080 by pi degrees. So leave like that, or want to convert, what you can do is 1080 by 22 by 7, right? By 7 I can multiply here, right? So if you start doing this, so what it will come as? It will come as a mixed. That mixed fraction I can write as 343,711. You divide that, is what you will get, degrees. So if you want to convert this into minutes and seconds, that also we can do, because 343 degree we know. So this we can write as 340 degrees, 343 degrees plus 7 by 11, right? So 7 by 11, I can convert this, 7 into 1 degree is what? 60 minutes, right? So 60 minutes by, so if I simplify this I will get as 343 degrees plus 38 minutes. And then I will be left with a fraction that is 2 by 11. 2 by 11 minutes. So for this minutes, if I want to convert this into a second, then it's 2 minutes by 1. So 60. That will give you in seconds. So that is 120 seconds by that. 120 by 11 means you can say 7 means 1. right? So that is 10 minutes. That's what you will get. So it is like 10.9 seconds we will get. So we can write this as 43 degrees plus 38 minutes plus 0.9 seconds. Or we can get like 43 degrees and 38 minutes and from to 11. So how we are doing this? You can safely live up to here, guys. Safely live up to that much degrees. Or if you want to convert that, substitute the pi value and that pi value, then you will get into a mixed fraction. Sometimes you'll get a whole value. Then you can just say 340 degrees if it is a perfect cancellation. You left with a mixed fraction. That mixed fraction you can convert into minutes by multiplying with 1 degree is 60 minutes, right? You into 60 and then simplify. Sometimes you will get a perfect value. So those many minutes you can write. If you don't get a perfect value, then you further simplify that into seconds. That how 1 minute, now you got the answer in minutes, right? That portion I'm saying. So that minutes you can convert into seconds by further multiplying with 60 because we know 1 degree is, because we know 1 degree is 60 minutes and 1 minute is 60 seconds. All right, guys. So that's how you can convert radians into degrees. Now, let's take some examples from your exercise. So now you have 3 degrees. Yeah, let's do this. So this is minus 47 degrees and 30 minutes. So this what you need to find the radian measure. So you need to convert this into radians. So first thing, what I need to do is see this 30 minutes I need to convert into degree. So 60 minutes is 1 degree. So 30 means it is 30 minutes equal to 30 by 60. That is half degree. It is basically right. So I can write this as 47 1 by 2. Or if I convert this into a proper fraction, this is a mixed fraction, right? So 47 twos, 94 plus 1. So 95. Hope you all know that what mixed fraction into a proper fraction. So this is minus 95 by, what is the multiplication factor? I know degree. I need to put it to radian. So then it is pi by 180. So this I can say uh, yeah, 95, 95, 90, this. Guys, sorry. No, with 9 I need to do. No, no. Let's let's take this guy. This is minus 95, right? So minus 95 by 2 into pi by 180. I think I can divide with 5 first. So 5 ones 5, 5 nines, right? This is 5 threes. Then you have 30, 5, 6, 30, right? So this is minus 19 pi by 72. Or you can just write uh, yeah, minus 19 pi by 72 radian. This is in minus. That means this is a clockwise angle. So minus 47 degree 30 minutes you can write as minus 19 pi by 72 radians. Now let's take any other example. Maybe this fourth one, like 520 degrees, right? So this 520 into what is the multiplication factor, guys? Pi by 180. So let's do this with P3. Yeah, 3 1s, 3 4s, 360s, right? 360s. So this is 14 pi by 6. Can I write like that? Or 2 3s? 7. So 7 pi by 3 radians. I can leave like that, or 7 into pi value. If you can substitute 22 by 7, then 7 gets cut. So you can say 22 by 3 radians. My suggestion will be you can leave up to here, 7 pi by 3 radians. Nobody looks at the calculation. Okay. So whether you have applied a proper multiplication factor and got the value converted from degrees to radians. That's what they care. All right. Now let's look at this. Another problem. So the minute hand of a watch is 1.5 centimeter long. So let's consider this as a watch. So here we have the center of the clock and the minutes hand. Okay, let's say we will start from the 12. Okay, so this is the minute hand whose length is 1.5 centimeter. Okay, the minute hand length, that means the radius of that. So we can consider the minutes hand length is nothing but the radius. Radius of that circle is 1.5 centimeter. How far does it tip move? So the tip, if the tip is here, how far that tip move is nothing but the circumference they are asking. Oh, in 40 minutes. So in 40 minutes, what will happen, guys? This will come up to here, up to 8, right? From 12 to 8. So how far does it move? Yeah. So the minute hand. So what we need to find, we basically need to find the circumference of this arc, the big arc. So there is a relation between the arc to the radius into theta. Theta is the angle. So if this is theta, then if we want to find this circumference, that is L, and this R, then L equal to R theta is the formula to find the length of the arc. So then we know the radius. Now we need to find theta. So how can we find theta? So for full rotation, clock 60 minutes, right? 60 minutes, it will rotate 360 degrees, right? 60 minutes, right? The whole clock, okay, 60 minutes. In 60 minutes, the minute hand will make 60 degrees. That is one. Now, what is for 40 minutes? 40 minutes, how much angle? So what you can do for 1 degree, how much? 360 into 40, right? 61, 66. So 64. So basically it is rotating by 240 degree. So from 12 to 8, which is 40 minutes. In 40 minutes, minute hand is making an angle of rotation of 240 degrees. Now, you know the formula L equal to R into what is R? R is 1.5. And here, guys, for finding the length of the R, you need to substitute the value in radians. That is important. You cannot substitute degree and find the centimeter, right? So first you convert this 240 degree into radians. So how much is the radians? Pi by 1. So yeah, 360s, 380s. So we can say 8 pi by 6, 0, okay? Or we can say 4 pi by, so 40, sorry, 240 degrees is 4 pi by 3. Yeah. Now, L equal to R theta, right? So R is 1.5 centimeter into this rate, this much radians, 4 pi by 3. That is 1.5 once, 1.5 2 once, 2. Basically, it is 2 pi. So 2 into 3.14. That is, if you want to convert, or you can just leave like a. So this is like a 0.8 centimeters. That is the length of the arc. That is the minute hands will cover when it moves in 40 minutes, in 40 minutes. So basically what we did, we converted this angle, that how much angle that minute hand is making. So in 40 minutes, it will make 360 by 16 40. That is 40 degrees it's making. That 240 degree we converted into radians, because when we are finding the length, the degree, you cannot substitute into degree, so we need to substitute in radians. So that is 240 into pi by 180. Then 3638, right? So yeah, 36 and 38. So that is 4 pi by 3. Correct, guys? Yeah. 360s, 380s. Yep. So 8 pi by 6, that is nothing but 4 pi by 3. So R is 1.5 and theta is 4 pi by 3. If I substitute, then I'll get it as 2 pi, which is 6.28 centimeters. You understood, guys? So that's how we can find. This problem is important. The minutes hand or hours hand they will give. So here the clue is the length of the hand is nothing but your radius. And then find how much angle that is making and convert that into radians and then substitute into the formula L equal to R theta. Okay, next. Look at these guys. This is also an important problem. A wheel makes 360 revolutions in 1 minute. So in 1 minute, a wheel is making 360 revolutions. Okay, that's the given data. Through how many radians does it turn in 1 second? So in 1 minute, if it is making 360 revolutions, 1 minute is nothing but 60 seconds, right? So 60 seconds, it is making how many? 360 revolutions. Okay. And in 1 second, how many revolutions it will make? That is 360 by 60 revolutions. You following, guys? So that means in 1 second, it's basically making 6 revolutions. So for one revolution, right? For one revolution, what is the radians? One revolution is nothing but what? 360 degrees, right? So 360 degrees is 2 pi radians, right? So how many revolutions it's making? 6 revolutions. So 6 into 2 pi radians. So I can say 12 pi radians. So basically, a wheel is making 360 revolutions. So how many radians does it turn in 1 second? 1 second, it turns 6 revolutions. Each revolution is 2 pi radian. So pi into 6, that is 1 pi radian. All right, another one. So in a circle of diameter 40 centimeter, okay, diameter is given. So then radius equal to 40 pi, which is 20 centimeter is the radius. The length of the chord is 20 centimeter. Okay. Find the length of the minor arc. Okay. So there is a circle, guys. Okay. So there is an arc. If there is an arc, it is around, it is the length of the chord. So join these two. That is the chord. This chord is 20 centimeter and this is radius, right? So this is R and this is R. Okay. Oh, chord is AB. So then delta OAB is a triangle. So what is R? R is also 20 centimeter here. So can I say this is an equilateral triangle? So we can say OAB, delta OAB is an equilateral triangle. So that's a good point. Right? So this forms an equilateral triangle. Now what we need to find? We need to find this L. L is nothing but the arc length. So what is the formula? L equal to R theta. But what is theta here? Theta is 60 degrees. An equilateral triangle. Can I say this is 60 degrees? Right? So this 60 degree, I need to convert into what? Radian. So 61. So I can say this is pi by 3 radian. Guys, so theta is pi by 3 radian. Okay. Substitute the value. What is L? L is 20 centimeters into pi by 3. So we can say 20 pi by 3 meters. That's the length of the arc. Or if you substitute the value, it's 0.1. Then you can find the value. Or you substitute the value or you can leave up here. It's basically applying your knowledge, right? So a circle is given, whose diameter and a chord is given. A chord length is given, which is 20. That's matching with the radius. That means all three sides of that B is forming an equilateral triangle. An equilateral triangle, each angle is 60 degrees. That we know. So find the length of the R. The formula L equal to R theta. R we know and theta is 60 degrees. That I converted into radians, which is pi by 3. So this is 20 pi by 3. This kind of problems they'll ask in the board exercise. Okay, now let's look at the real life application. Okay, we learned about how to convert degrees, how to convert the rotation and where we use this. So we use in real life measuring the angles in physics, like circular motion, like water motion. So those we find or the length, whatever, right? In this formula, radians, uh, then engineering and computer graphics, angle rotation. So in a CAD CAM, to draw some designs and all these degrees, radians. Also trigonometry and calculus. So like how we use in trigonometry and calculus for calculating. Uh, if we know the rotation, like what is the length that it has covered? So meters, we can use this degree to radian conversion, and that will be helpful to us. That's a real life applications where we use them. Now, let's look at the summary. So, what is the summary degree? So, 1 degree is 1 by 360th portion of the revolution. 1 degree is. Right, guys? And also what we learn, 1 degree is nothing but minutes. 1 minute is nothing but 50 seconds. That's what we learn. And then what is a radian? Radian is in a unit circle. A unit circle. So 360 degree. The total rotation is 2 pi. That means 2 pi radians, or 180 degrees equal to pi radians. This is what we learned, right? So 1 radian equal to 180 degrees by pi. If you want to convert into degrees. And if you need 1 degree, then it is pi by 180 radians. Guys, this is the conversion. We need to remember 180 is pi radians. And then we also practiced both ways, like converting from degrees to radians and radians. Now, let's do some practice work. So this slide covers try degrees into radians. The only thumb rule is what you need to remember. So if you want to convert degrees into radians, it is pi by 180. If you want radians into uh, degrees, then it is 180 by pi. That's the multiplication. This you can try. You have any questions? Yeah, that's all today's session, guys. So hope you understood. And if you have any queries or thanks for your time.